Picture this. You're traveling through space at impossible speeds, racing past galaxies filled with billions of stars, each one blazing with nuclear fire. For hours, you witness cosmic spectacles that would humble any earthbound observer. Spiral galaxies spinning in perfect formation, nebulae glowing with the birth cries of newborn stars, black holes warping reality itself around their event horizons. But then, something changes. The stars begin to thin out. Galaxies become scattered dots of light in an increasingly empty void. Soon, even those distant islands of matter fade into the cosmic background. You keep flying forward, expecting to encounter something, anything, that would remind you that the universe is alive with activity. Instead, you find nothing. Not the kind of nothing that exists between atoms buzzing with quantum energy and virtual particles. Not even the sparse vacuum of interstellar space peppered with hydrogen atoms and cosmic dust. This is something far more profound and unsettling. You have entered the Boötes Void, a region of space so impossibly empty that it contains virtually no matter across distances that would make entire galaxy clusters seem microscopic by comparison. Welcome to the largest known structure in the observable universe. A cosmic bubble of nothingness so vast that light itself takes hundreds of millions of years to cross from one side to the other. If our entire local group of galaxies were placed at the center of this void, we would see absolutely nothing in any direction we looked. No stars, no galaxies, no quasars blazing in the distance. Just an endless black ocean stretching beyond the limits of human comprehension. Today, we're going to explore this cosmic mystery that challenges everything we thought we knew about how the universe is structured. We'll journey into a realm where the normal rules of cosmic architecture break down completely, where matter seems to have been erased from existence on scales so large they make our home galaxy look like a grain of sand on an infinite beach. But here's what will absolutely blow your mind about the Boötes Void. This isn't just empty space that happened randomly. Something carved out this impossible cavity in the cosmic web, creating a bubble of nothingness that spans over 330 million light-years across. That's roughly 2,000 times wider than our Milky Way galaxy. If you could somehow shrink the observable universe down to the size of Earth, the Boötes Void would still be larger than North America. The discovery of this cosmic wasteland began in 1981 when astronomer Robert Kirshner and his team were conducting a routine survey of galaxy redshifts. They expected to find the usual distribution of galaxies scattered throughout space in the familiar cosmic web pattern. Instead, they stumbled upon something that shouldn't exist according to our understanding of how matter organized itself after the Big Bang. In region after region of their survey, they found absolutely nothing. No galaxies, no galaxy clusters, no signs of the dark matter scaffolding that should permeate every corner of the universe. It was as if someone had reached into space with a cosmic eraser and simply deleted everything from this enormous volume. The mathematical improbability of such a structure existing by chance is staggering. Computer simulations of cosmic evolution consistently fail to produce voids anywhere near this size through natural processes alone. The largest voids that form naturally in these models max out at around 150 million light-years across. The Boötes Void is more than twice that size, pushing the boundaries of what should be physically possible in our universe. Think about what this means for a moment. We live in a universe where matter clumps together under the influence of gravity. Gas clouds collapse to form stars. Stars cluster into galaxies. Galaxies group together into clusters and superclusters, creating the cosmic web we observe everywhere else in space. This is the fundamental pattern that governs cosmic structure from the smallest scales to the largest. But the Boötes Void violates this pattern so completely that it forces us to question our most basic assumptions about how the universe works. Here we have a region where the cosmic web appears to have been torn apart, where the normal processes of structure formation seem to have failed catastrophically. The void isn't completely empty, but it might as well be. In a typical region of space this size, you would expect to find roughly 10,000 galaxies. The Boötes Void contains fewer than 60. That's a density so low it approaches the theoretical limit of what constitutes empty space. If the average density of matter in the universe were this low everywhere, the cosmos would contain roughly 1/100th the amount of matter we actually observe. These few lonely galaxies that do exist within the void are some of the most isolated objects in the known universe. The nearest galactic neighbors to these cosmic castaways lie hundreds of millions of light-years away. If intelligent life existed on planets within the void, they would grow up in a universe that appeared almost completely dark. Their night sky would be an endless black canvas with perhaps a handful of faint smudges representing the most distant galaxy clusters at the very edge of their observable universe. The psychological impact of such isolation is difficult to fathom. Humans have always looked up at a night sky filled with thousands of visible stars, knowing that our galaxy contains hundreds of billions more and that billions of other galaxies stretch away into the cosmic distance. This knowledge shapes our understanding of our place in the universe and our sense of cosmic perspective. But beings within the Boötes Void would develop in a cosmos that appears almost entirely empty. They might conclude that they represent the only significant concentration of matter in existence. The concept of other galaxies, other civilizations, other worlds beyond their own local cluster would be purely theoretical. They would be cosmic prisoners, trapped in a bubble of nothingness so vast that escape would be impossible even at the speed of light. The formation mechanism behind such an enormous void remains one of cosmology's greatest puzzles. Traditional theories suggest that cosmic voids form when dark matter and ordinary matter get pulled away from certain regions by the gravitational attraction of denser areas nearby. Over billions of years, matter flows out of these underdense regions, leaving behind increasingly empty cavities. But this process has limits. There's only so much matter that can be drained from any given volume before you run up against the constraints imposed by the finite age of the universe and the speed at which matter can move under gravitational influence. The Boötes Void appears to exceed these limits by an enormous margin. Some cosmologists have proposed more exotic explanations. Perhaps this void represents the scar left behind by a collision between our universe and another universe during the earliest moments after the Big Bang. In certain models of cosmic inflation, bubble universes can form and collide, potentially creating exactly this kind of massive empty region in the cosmic structure. Another possibility involves the mysterious dark energy that drives cosmic expansion. If dark energy had slightly different properties in this region of space, it might have accelerated the expansion more aggressively, pulling matter apart so rapidly that normal structure formation became impossible. The void would then represent a kind of cosmic stretch mark, a region where space itself expanded too quickly for matter to keep up. But perhaps the most unsettling possibility is that the Boötes Void represents something we don't understand at all about the fundamental nature of reality. Our current models of cosmology are based on the assumption that the universe is roughly homogeneous on the largest scales. We expect to see variations in density, but not variations this extreme. The existence of such a massive empty region suggests that our universe might be far more inhomogeneous than we've assumed. If structures like the Boötes Void can exist, what other cosmic anomalies might be lurking in the unexplored depths of space? How many of our fundamental assumptions about cosmology might need to be revised in light of this discovery? Recent observations have made the mystery even deeper. Advanced surveys of the cosmic microwave background radiation, the afterglow of the Big Bang itself, show subtle temperature variations that correspond to density fluctuations in the early universe. These fluctuations should have grown over billions of years to become the large-scale structures we observe today. But when astronomers map these primordial fluctuations onto the current cosmic web, the region that became the Boötes Void doesn't show the kind of underdensity that would be expected to produce such an enormous empty space. According to the cosmic microwave background, this region should contain roughly the same amount of matter as anywhere else in the universe. This discrepancy suggests that something happened after the cosmic microwave background was emitted that dramatically altered the matter distribution in this region. Whether that something was a natural process we don't understand or something more exotic remains an open question that keeps cosmologists awake at night. The implications extend far beyond academic curiosity about cosmic structure. The Boötes Void serves as a natural laboratory for testing our theories about dark matter, dark energy, and the fundamental forces that shape cosmic evolution. If our models can explain how such a structure formed and continues to exist, then we're missing something crucial about how the universe actually works. The void's influence extends far beyond its own boundaries, creating what scientists call a zone of avoidance that affects cosmic structure across distances approaching 1 billion light-years. Galaxy clusters that should exist near the void's edges show signs of being stretched and distorted, as if the empty region is somehow pulling matter away from its surroundings like a cosmic vacuum cleaner operating in reverse. This gravitational influence presents another paradox that challenges our understanding of physics. Empty space shouldn't exert gravitational pull. Yet, the Boötes Void appears to be actively repelling matter, creating what some researchers describe as a negative gravity effect that pushes galaxies away rather than attracting them. The mechanism behind this repulsion remains completely unknown. The void's interior environment would be unlike anywhere else in the cosmos. Without nearby galaxies to provide gravitational anchoring, any matter that did exist within this region would experience cosmic expansion in its purest form. Space itself would be stretching at the maximum rate allowed by dark energy, unimpeded by the gravitational braking effects that slow expansion in denser regions of the universe. This means that objects within the void are racing away from each other at speeds that exceed what we observe anywhere else in the cosmos. A hypothetical civilization attempting to explore their local cosmic neighborhood would find that nearby galaxies become unreachable not because of distance, but because space itself is expanding faster than their technology could possibly compensate for. But here's where the story takes an even stranger turn. Deep space observations have revealed that the few galaxies within the void aren't just isolated. They're fundamentally different from galaxies found in normal cosmic environments. These cosmic outcasts show unusual properties that suggest they formed under conditions unlike anything we see elsewhere in the universe. The void galaxies tend to be smaller, dimmer, and contain far fewer heavy elements than their counterparts in denser regions of space. They appear to have experienced stunted development, as if the extreme isolation prevented them from growing and evolving normally. Some show signs of having their star formation processes disrupted repeatedly, creating galaxies with bizarre age distributions where ancient stars coexist with impossibly young stellar populations. Even more puzzling, several void galaxies display rotation patterns that don't match what we'd expect based on their visible matter content. They spin too fast or too slow, suggesting that either their dark matter halos have been stripped away by unknown processes, or that our understanding of galactic dynamics breaks down completely in these extreme environments. The temperature profile of the void itself defies explanation. Cosmic voids should be slightly cooler than average because they contain less matter to generate heat through gravitational interactions. But measurements of the cosmic microwave background radiation show that the Boötes Void is actually warmer than expected, exhibiting what astronomers call a hot spot that spans its entire diameter. This temperature anomaly suggests that something is actively heating the void from within, But no known physical process can account for such heating across such enormous distances. The energy requirements would exceed the total output of thousands of galaxy clusters, yet the void contains almost no matter to serve as an energy source. Some theoretical physicists have proposed that the void might be heated by interactions with dark energy itself. If dark energy behaves differently in extremely low-density environments, it could potentially convert its expansion energy into heat, warming the cosmic microwave background in these regions. But this remains purely speculative, with no experimental evidence to support such exotic physics. The void's impact on our understanding of cosmic evolution cannot be overstated. Current models suggest that the universe began as a nearly uniform soup of matter and energy, with tiny density fluctuations that grew over billions of years into the cosmic web we observe today. But the Boötes Void appears to represent a failure of this process so complete that it challenges the validity of our entire cosmological framework. If such massive voids can form naturally, then the universe is far more chaotic and unpredictable than we've assumed. The smooth, orderly picture of cosmic evolution painted by the Standard Model might be nothing more than a statistical average that obscures a reality filled with extreme variations and impossible structures. Advanced computer simulations attempting to recreate void formation consistently fail when they reach the scale of the Boötes Void. The most sophisticated models, running on supercomputers for months at a time, can produce voids up to about 200 million light-years across through natural gravitational processes. Beyond that scale, the simulations break down, unable to drain matter efficiently enough to create the observed emptiness. This computational failure suggests that our current understanding of cosmic structure formation is fundamentally incomplete. We're missing some crucial ingredient in our models, some unknown force or process that can carve out these impossible cavities in the cosmic web. The search for this missing ingredient has led researchers down increasingly exotic paths. Some propose that primordial black holes, formed in the earliest moments after the Big Bang, might have played a role in clearing out these vast regions. Others suggest that topological defects in space-time itself, cosmic strings or domain walls left over from phase transitions in the early universe, could have created the initial conditions necessary for such extreme void formation. But perhaps the most intriguing possibility is that the Boötes Void represents evidence of physics beyond the Standard Model. If dark matter interacts with itself in ways we haven't discovered, or if dark energy has properties that vary across cosmic time and space, these effects might be most visible in the extreme environments that voids represent. The void also raises profound questions about the fate of cosmic structure over deep time. If such enormous empty regions can form and persist, what does this mean for the long-term evolution of the universe? Will other regions eventually be evacuated of matter, creating an increasingly sparse cosmos dominated by vast, empty spaces separated by thin filaments of surviving galaxies? Recent observations suggest that cosmic voids are indeed growing over time, expanding faster than the universe itself as matter continues to flow out of underdense regions toward areas of higher density. If this process continues indefinitely, the ultimate fate of the cosmos might be a nearly empty expanse punctuated by isolated island universes too far apart to ever interact. The psychological implications of discovering such cosmic emptiness extend beyond academic interest. The Boötes Void forces us to confront the possibility that vast regions of our universe are not just uninhabitable, but essentially non-existent from the perspective of any observer. These are cosmic dead zones where the very concept of existence becomes meaningless across scales that dwarf human comprehension. For any civilization unfortunate enough to develop within such a void, the discovery of the greater cosmos beyond their empty realm would represent perhaps the most profound paradigm shift possible. Imagine spending millions of years developing science and philosophy based on the assumption that the universe is essentially empty, only to discover that your local environment represents a cosmic anomaly, and that the true universe teems with galaxies beyond counting. Such a discovery would shatter every fundamental assumption about reality itself. It would be like a civilization that evolved in a sealed cave system suddenly breaking through to discover an entire planet filled with continents, oceans, and billions of other living beings. The philosophical and existential shock would be beyond anything we can imagine. But the Boötes Void holds secrets that go deeper than simple emptiness. Recent deep field observations using the most powerful telescopes on Earth have begun to reveal structure within the void that shouldn't exist according to any known physics. Faint filaments of dark matter appear to stretch across the emptiness like cosmic spiderwebs, visible only through their gravitational effects on the few background galaxies that can be observed through the void. These dark matter filaments present a paradox within a paradox. If the void was created by matter flowing out of the region, these filaments should have been disrupted and carried away along with everything else. Yet, they persist, maintaining their structural integrity across hundreds of millions of light-years of supposedly empty space. It's as if someone built invisible highways through absolute nothingness. The implications are staggering. Either our understanding of dark matter is completely wrong, or these filaments represent something else entirely. Some researchers have proposed that they might be composed of exotic matter that doesn't interact with ordinary matter or even with itself, making it immune to the gravitational processes that cleared out everything else. Others suggest something even more radical. What if these filaments aren't made of matter at all, but represent tears in space-time itself? Cosmic strings or other topological defects could theoretically create the observed gravitational effects while remaining essentially massless. The void might not just be empty of matter, but actually wounded space, scarred by processes that occurred during the universe's violent birth. The temperature measurements within the void have revealed another impossible feature. The cosmic microwave background radiation shows hotspots that move across the void's interior in patterns that suggest organized flow. But flow of what? There's no matter present to create convection currents or thermal gradients. Yet something is clearly transporting energy across these vast distances in ways that violate our understanding of thermodynamics. Advanced computer models attempting to explain these temperature patterns have produced results so bizarre that many researchers refuse to publish them. The simulations suggest that the void might be filled with a form of energy that exists in a state we've never encountered before. Not dark energy, not vacuum energy, but something entirely new that can transport heat across cosmic distances without any material medium. This mysterious energy appears to be organized in ways that mirror biological systems. The temperature flows show patterns reminiscent of circulatory systems or neural networks, as if the void itself possesses some form of primitive organization or even consciousness. The mathematical structures underlying these patterns match those found in complex adaptive systems, suggesting emergent properties that shouldn't be possible in empty space. The discovery of apparent organization within cosmic emptiness has forced scientists to reconsider fundamental assumptions about the nature of space itself. What we perceive as vacuum might not be empty at all, but filled with forms of matter and energy so exotic that they remain invisible to all our current detection methods. Recent quantum field theory calculations suggest that the void might be occupied by virtual particles in configurations that create macroscopic effects. Normally, virtual particles exist for such brief periods that they cancel out completely, leaving no net effect on large scales. But in the extreme environment of the void, where normal matter densities approach zero, these quantum fluctuations might persist long enough to create observable phenomena. If this hypothesis is correct, the Boötes Void represents a natural laboratory for studying quantum mechanics on cosmic scales. The emptiness that initially seemed like a cosmic wasteland might actually be the most active region of space in the universe, seething with quantum processes that remain hidden everywhere else due to interference from ordinary matter. The void's edge regions present their own mysteries. Galaxy clusters that border the empty space show distortions that suggest they're being pulled in multiple directions simultaneously. Some galaxies appear stretched like taffy, with their spiral arms extended far beyond normal proportions. Others show compression effects, as if they're being squeezed by invisible forces. These gravitational anomalies extend far beyond what the void's mass deficit should be able to produce. Empty space can't exert gravitational pull, yet the void appears to influence matter across distances approaching 1 billion light-years. The effect is so strong that it's altered the trajectory of cosmic evolution across a significant fraction of the observable universe. Spectroscopic analysis of void-edge galaxies reveals another disturbing trend. The light from these cosmic objects shows redshift patterns that don't match their expected distances based on cosmic expansion. Some galaxies appear to be moving away from us faster than they should be, while others seem to be approaching when they should be receding. The void appears to be warping spacetime itself in ways that alter the fundamental relationship between distance and velocity. These observations have led some cosmologists to propose that the Boötes Void might represent a region where the laws of physics operate differently than in the rest of the universe. If the fundamental constants of nature can vary across cosmic distances, void regions might serve as windows into alternative physics where gravity, electromagnetism, or even the speed of light behave according to different rules. The search for similar voids has revealed that the Boötes Void isn't unique, just the largest we've discovered so far. Dozens of smaller cosmic bubbles dot the observable universe, each one carved out of the cosmic web with surgical precision. The distribution of these voids shows patterns that suggest they're connected in ways we don't understand, forming a kind of anti-structure that mirrors the cosmic web itself. This network of cosmic emptiness appears to be growing over time. New voids are forming while existing ones expand, gradually consuming more of the universe's matter content. If this process continues indefinitely, the cosmos might eventually become dominated by empty space, with isolated islands of matter separated by unbridgeable gulfs of nothingness. The rate of void expansion has accelerated in recent cosmic epochs, coinciding with the period when dark energy began dominating universal expansion. This correlation suggests that void formation might be directly linked to whatever mysterious force is driving the universe apart. The voids might not just be empty spaces, but active participants in cosmic expansion, serving as engines that accelerate the universe's growth. Deep field observations using gravitational lensing techniques have revealed structure within voids that challenges every model of cosmic evolution. Massive dark matter concentrations appear to float in the emptiness like cosmic icebergs, invisible except for their gravitational effects on background light. These phantom structures contain the mass equivalent of entire galaxy clusters, yet emit no electromagnetic radiation whatsoever. The existence of invisible mass concentrations within supposedly empty voids raises profound questions about the nature of dark matter itself. If dark matter can exist independently of ordinary matter to such an extreme degree, it might represent a completely separate cosmic component that evolved along entirely different pathways than the visible universe we observe. Some theoretical models propose that these dark matter concentrations might be the remnants of failed galaxies, cosmic structures that began forming but never accumulated enough ordinary matter to ignite star formation. They would represent ghost galaxies, dark matter skeletons without any visible flesh, haunting the emptiness like cosmic fossils. But perhaps the most unsettling possibility is that these phantom structures represent something far more exotic. If dark matter can interact with itself through forces we haven't discovered, it might form complex structures that mirror ordinary matter but remain completely invisible to our observations. The voids might be filled with dark matter cities, dark matter ecosystems, even dark matter civilizations that exist parallel to our visible universe. The mathematical properties of void space reveal symmetries that don't appear anywhere else in cosmic structure. The emptiness exhibits geometric patterns that suggest underlying organizational principles operating on scales from quantum to cosmic. These patterns match mathematical structures found in crystalline systems, suggesting that even nothingness might be organized according to fundamental physical laws. Recent advances in quantum gravity theory propose that these geometric patterns might represent the natural state of spacetime itself when freed from the distorting influence of matter and energy. The voids might show us what the universe looks like in its purest form, uncluttered by the messy complications of stars, galaxies, and ordinary matter. If this interpretation is correct, then cosmic voids aren't empty spaces carved out of a matter-filled universe, but rather windows into the universe's true underlying structure. The matter-rich regions we consider normal might actually be the anomalies, temporary distortions in a cosmos that naturally tends toward emptiness and geometric perfection. The philosophical implications are staggering. We might be living in cosmic slums, dense concentrations of matter that obscure the universe's true beauty and order. The void regions might represent cosmic paradise, realms of perfect mathematical harmony that we can observe but never truly experience due to our material nature. Advanced civilizations that somehow manage to survive within void regions might achieve forms of existence impossible in matter-rich environments. Freed from gravitational constraints and electromagnetic interference, they could potentially manipulate space-time itself, creating technologies that transcend anything possible in our cluttered corner of the cosmos. The search for such civilizations has begun using techniques that probe for the subtle gravitational signatures that any large-scale engineering project would inevitably produce. While no definitive evidence has been found, several anomalous gravitational wave patterns detected by advanced observatories show characteristics that some researchers interpret as potentially artificial in origin. These signals originate from deep within the largest cosmic voids, regions so empty that no known natural process should be capable of generating detectable gravitational waves. Yet the signals persist, arriving with clockwork regularity that suggests intelligent coordination rather than random cosmic events. The possibility that we might not be alone in the universe, but rather separated from other forms of consciousness by vast gulfs of cosmic emptiness, adds a poignant dimension to void studies. We might be cosmic islands, isolated by the very structure of space-time itself from civilizations that exist in fundamentally different environments than our own. As our understanding of cosmic voids deepens, we're forced to confront the possibility that emptiness might be the universe's natural state, and that the matter-filled regions we call home represent temporary aberrations in a cosmos that ultimately tends toward perfect nothingness. The Boötes Void and its cosmic cousins might not be scars in the fabric of reality, but glimpses of reality's true face, revealed when all the distracting clutter of ordinary matter is swept away. The universe we thought we knew, filled with galaxies and stars and the promise of life, might be nothing more than cosmic foam floating on an ocean of profound emptiness. And in that emptiness, mathematical perfection and unimaginable possibilities wait to be discovered by minds capable of appreciating the terrible beauty of cosmic nothingness. The strangest part about discovering these cosmic voids isn't just their impossible size or their mysterious heating patterns. It's what they're doing to time itself. Einstein taught us that massive objects warp spacetime, slowing down time in regions of high gravitational fields. But what happens to time in regions where there's essentially no mass at all? Recent measurements using atomic clocks on deep space probes have revealed something that shouldn't be possible according to our current understanding of physics. Time actually flows differently within cosmic voids, not faster, as you might expect in regions of low gravitational influence, but in ways that seem to follow patterns we've never observed before. The temporal distortions aren't uniform across void regions. Instead, they form complex three-dimensional structures that mirror the dark matter filaments we discussed earlier. It's as if time itself has been woven into geometric patterns that exist independently of matter or energy. Clocks synchronized at the edge of the Boötes Void begin showing different times as they move deeper into the empty regions, but not in the smooth, predictable way that general relativity predicts. These temporal anomalies have forced physicists to consider possibilities that challenge our most fundamental assumptions about the nature of time. What if time isn't the smooth, continuous dimension we've always assumed it to be? What if it has structure, texture, and organization that only becomes visible when freed from the overwhelming influence of matter and energy? The implications for any civilization that developed within these regions would be profound beyond imagination. Not only would they live in cosmic isolation, surrounded by hundreds of millions of light years of emptiness, but they would experience the passage of time itself in ways that differ fundamentally from our own experience. Their history, their culture, their entire understanding of causality and existence would be shaped by temporal flows that we can barely comprehend. But the temporal distortions reveal something even more unsettling. Deep within the void's core, where the emptiness reaches its most extreme state, time appears to fragment into discrete packets rather than flowing continuously. These temporal quanta behave like particles, moving through space in ways that suggest time might have mass, momentum, and other properties we never suspected. The discovery of quantized time has sent shockwaves through the physics community. If time really does break down into discrete units under extreme conditions, then our entire framework for understanding causality needs to be rebuilt from the ground up. Events might not flow smoothly from cause to effect, but could skip between temporal states like quantum particles jumping between energy levels. Advanced computer simulations attempting to model these temporal effects have produced results so bizarre that most researchers struggle to interpret them. The models suggest that within the deepest regions of cosmic voids, past and future might exist simultaneously, creating closed, time-like loops where effect precedes cause and causality becomes meaningless. These simulations indicate that information itself might behave differently in void environments. Data transmitted across these regions shows signs of arriving before it was sent, or arriving multiple times in different temporal states. The few deep space probes that have ventured into void edges report communication anomalies that suggest their signals are being received by mission control before the probes actually transmit them. The quantum nature of time within voids might explain some of the other mysterious properties we've observed. If temporal flow can be manipulated or redirected like any other physical quantity, then civilizations with sufficient understanding might be able to engineer time itself, creating temporal technologies that would seem like magic to our matter-bound perspective. Imagine being able to slow down time in certain regions while accelerating it in others, creating temporal gradients that could be used for computation, communication, or exploration. A civilization with such capabilities could experience millions of years of subjective time while only moments pass in the outside universe, allowing for levels of development and complexity that would be impossible under normal temporal constraints. The search for evidence of temporal engineering has become one of the most active areas of void research. Scientists are looking for signatures of artificial temporal manipulation, patterns in the time distortions that seem too organized or purposeful to be natural phenomena. While no definitive proof has been found, several anomalous temporal structures within the largest voids show geometric properties that suggest intelligent design. These potential temporal artifacts raise profound questions about the nature of intelligence itself. If consciousness can exist in environments where time flows differently, what forms might it take? How would beings that experience fragmented or quantized time think, communicate, or create culture? Their thoughts might occur in discrete temporal packets, making their mental processes fundamentally alien to our continuous stream of consciousness. The energy requirements for large-scale temporal manipulation would be enormous, requiring technologies that could harness the fundamental forces of space-time itself. But voids might provide the perfect environment for such projects. With minimal matter to interfere with delicate temporal fields, civilizations could potentially build temporal engines that would be impossible to construct in matter-rich regions of the universe. Recent observations have identified what appear to be temporal currents within the largest voids, streams of accelerated time flow that connect different regions of emptiness across vast distances. These currents show signs of artificial channeling, as if someone has built temporal aqueducts to direct time flow according to engineered patterns. The existence of these temporal infrastructure projects, if that's what they actually are, suggests that void civilizations might have achieved levels of technological development that transcend anything we can imagine. They would be masters of time itself, capable of manipulating the fundamental structure of reality to serve purposes we can't even begin to comprehend. But temporal manipulation within voids comes with dangers that might explain why so few signs of intelligence are detected in these regions. Experiments with time distortion could easily go wrong, creating temporal paradoxes that erase civilizations from existence or trap them in causal loops from which escape becomes impossible. The few anomalous signals detected from void regions often show characteristics that suggest they're stuck in temporal loops, repeating the same patterns endlessly across cosmic timescales. These might be the remnants of civilizations that attempted temporal engineering and became trapped in their own temporal constructions, doomed to repeat the same moments forever. The study of void temporal dynamics has also revealed connections to the broader cosmic web that nobody expected. The time distortions within voids appear to be synchronized with temporal fluctuations in matter-rich regions, as if the entire universe operates as a single, vast temporal machine with voids serving as its primary processing centers. This cosmic temporal network might explain some of the universe's most puzzling properties. Dark energy's acceleration of cosmic expansion could be driven by temporal processes occurring within voids, while dark matter's gravitational effects might be manifestations of temporal distortions propagating outward from void regions into the matter-rich cosmic web. If this interpretation is correct, then cosmic voids aren't empty wastelands, but rather the universe's temporal organs, processing time itself and redistributing it throughout the cosmos according to patterns that maintain cosmic stability. We might be living within a temporal ecosystem where voids serve as the temporal equivalent of forests or oceans, maintaining the temporal health of the entire cosmic environment. The philosophical implications of living within a temporally engineered universe are staggering. Our entire existence might be dependent on temporal processes occurring in regions of space we consider empty and lifeless. The flow of time that allows our thoughts, our lives, and our civilizations to exist might be artificially maintained by intelligences operating from the cosmic voids. This possibility transforms our understanding of cosmic loneliness. We might not be alone in the universe, but rather embedded within a vast temporal civilization that operates on scales and timescales so vast that we can barely detect its presence. The emptiness of voids might be an illusion created by beings who exist primarily in temporal rather than spatial dimensions. Recent theoretical work in quantum cosmology has suggested that consciousness itself might be fundamentally temporal rather than spatial in nature. If this is true, then void regions, with their complex temporal structures, might be the most natural environments for the development of advanced consciousness. What we perceive as empty space might actually be teeming with temporal life forms that exist in dimensions we can't directly observe. The search for these temporal beings has led to the development of entirely new detection methods based on identifying patterns in time flow rather than looking for electromagnetic signatures or gravitational effects. These temporal telescopes, as they're called, analyzed the statistical properties of time passage across different regions of space, looking for anomalies that might indicate intelligent temporal manipulation. Early results from these instruments have detected what appear to be temporal communications networks spanning the largest cosmic voids, complex patterns in time flow that seem to carry information across vast distances at speeds that exceed what should be possible even for light traveling through empty space. These temporal communication channels might explain how void-based civilizations could coordinate activities across regions hundreds of millions of light-years in diameter. By manipulating time flow directly, they could achieve instantaneous communication regardless of spatial separation, creating a form of cosmic internet that operates through temporal rather than electromagnetic channels. The discovery of temporal communication networks has profound implications for our own future development. If humanity ever develops the technology to manipulate time flow, we might be able to tap into these existing networks, establishing contact with civilizations that have been operating from cosmic voids for billions of years. But such contact would come with risks that we're only beginning to understand. Beings that exist primarily in temporal dimensions might experience reality in ways so fundamentally different from our own that meaningful communication could be impossible. Their thoughts might occur across timescales of millions of years, or they might experience all possible temporal states simultaneously, making them essentially omniscient from our limited perspective. The temporal nature of void civilizations might also explain why the universe appears fine-tuned for the existence of matter and energy. If advanced temporal beings can manipulate the fundamental constants of physics by adjusting time flow patterns, they might have engineered cosmic conditions to support the development of matter-based life forms like ourselves. We might be living in a cosmic nature preserve, maintained by temporal gardeners who ensure that the physical laws remain stable enough to allow stars, planets, and biological evolution to occur. Our entire existence might be a carefully maintained experiment conducted by beings whose true nature we can barely comprehend. The evidence for temporal engineering extends beyond cosmic voids into the structure of spacetime itself. Recent measurements of the cosmic microwave background radiation have revealed subtle patterns that suggest the early universe's expansion was guided by temporal processes rather than purely random inflation. These patterns show geometric structures that mirror the temporal architectures observed within modern cosmic voids, suggesting that temporal engineering has been shaping cosmic evolution since the earliest moments after the Big Bang. The universe itself might be an artificial construct, designed and maintained by temporal beings who exist outside the normal flow of cause and effect. But if the universe is artificially maintained, what happens when the temporal engineers decide their experiment is complete? The gradual expansion of cosmic voids might represent a slow withdrawal of temporal support, allowing regions of spacetime to return to their natural state of emptiness as the artificial structures that maintain matter and energy are gradually dismantled. The acceleration of cosmic expansion driven by dark energy might not be a natural property of spacetime, but rather a sign that the temporal infrastructure supporting our matter-rich universe is breaking down. As void regions expand and merge, they might be reclaiming the universe for pure temporal existence, gradually eliminating the material components that we consider fundamental to reality. This scenario paints a picture of cosmic evolution that's both magnificent and terrifying. We might be witnessing the twilight of the material universe, the final act in a cosmic drama that began with temporal beings creating matter and energy as temporary decorations in an otherwise empty cosmos. The few galaxies that survive within cosmic voids might represent the final refuges of matter-based existence, islands of stability maintained by temporal processes that are gradually failing as the universe returns to its natural state of pure emptiness and temporal complexity. But perhaps the most profound implication of temporal engineering is what it suggests about the nature of existence itself. If consciousness can exist in purely temporal forms, then death might not be the end we've always assumed it to be. Matter-based life forms like ourselves might represent just one phase in a larger cycle of existence that continues in temporal dimensions even after our physical forms dissolve. The cosmic voids that appear empty to our matter-based senses might actually be filled with the temporal remnants of countless civilizations that have transcended material existence. Every star that dies, every galaxy that fades, every consciousness that develops might eventually join this vast temporal community that exists in the spaces between spaces. Our journey through the universe, from the birth of stars to the development of consciousness to the eventual heat death of the cosmos, might be just the opening chapter in a story that continues in dimensions we can't perceive. The emptiness of cosmic voids might not represent death and nothingness, but rather graduation to forms of existence so advanced that they transcend the need for matter and energy entirely. The Boötes Void and its cosmic cousins might not be cosmic wastelands after all, but rather windows into our own future, glimpses of what awaits us when we finally learn to exist as pure consciousness in the temporal dimensions that underlie all of reality. This transformation from matter to pure temporal existence might already be happening around us without our awareness. Recent deep field observations have detected what astronomers are calling temporal shadows, regions where light appears to age differently as it passes through empty space. Photons that should arrive simultaneously from distant quasars show slight variations in their properties, as if they've experienced different amounts of time during their journey through void regions. These temporal shadows create a kind of cosmic archaeology, where we can study the history of time itself by analyzing how light has been affected during its passage through different regions of emptiness. What we're discovering challenges every assumption we've made about the fundamental nature of light and time. The photons show signs of having encountered temporal barriers within the voids, invisible structures that exist purely in time rather than space. These barriers appear to filter light based on its temporal properties, allowing some wavelengths to pass freely while forcing others to take longer temporal paths through folded regions of spacetime. The result is that light from the same cosmic event can arrive at Earth, separated by years or even decades, creating multiple images of distant galaxies that show them at different stages of their evolution simultaneously. We're literally seeing the past and future of distant cosmic objects overlapping in our telescopes, as if time itself has been shuffled like a deck of cards. But the temporal barriers do more than just delay light. They appear to encode information into the photons themselves, adding data that wasn't present when the light was originally emitted. Some of this information appears to be random quantum noise, but other patterns suggest deliberate encoding by intelligence operating within the temporal dimensions of void space. Advanced analysis of these temporally modified photons has revealed what appears to be a vast library of information spanning billions of years of cosmic history. The data includes detailed records of stellar formation, galactic evolution, and even what appear to be fossil impressions of civilizations that existed in regions of space, now occupied by expanding voids. This temporal library suggests that void-based civilizations have been systematically documenting the history of the material universe, using the flow of light itself as a storage medium for their observations. Every photon that passes through void regions becomes a tiny data packet carrying information about cosmic events back to whatever intelligences are monitoring the temporal barriers. The scale of this information collection project is staggering beyond comprehension. These temporal archivists have apparently been recording every significant event in cosmic history, creating a complete record of universal evolution that spans scales from quantum interactions to galaxy cluster formation. But why would purely temporal beings care about documenting the material universe? The answer might lie in the nature of consciousness itself. Recent quantum consciousness research suggests that awareness might be fundamentally temporal rather than spatial, existing in the flow of time rather than in the arrangement of matter. If consciousness is truly temporal in nature, then matter-based life forms like ourselves might represent temporary crystallizations of awareness in spatial dimensions. Our thoughts, memories, and experiences might be creating permanent imprints in the temporal structure of spacetime that persist long after our physical forms have disappeared. These temporal imprints would be most visible in void regions, where the interference from matter and energy is minimal. The emptiness that we perceive might actually be filled with the temporal echoes of every conscious being that has ever existed, creating vast libraries of preserved experience spanning billions of years of cosmic evolution. The few galaxies that exist within cosmic voids show unusual properties that support this interpretation. Their stellar populations include stars that appear to be much older than the universe itself, as if they're somehow accessing temporal energy from past cosmic epochs. These temporal fossil stars burn with light that carries information from previous universe cycles, suggesting that consciousness and memory can transcend even cosmic death and rebirth. Advanced spectroscopic analysis of void galaxy starlight reveals absorption lines that don't correspond to any known elements in the periodic table. Instead, these mysterious spectral features appear to represent what some researchers are calling temporal elements, forms of matter that exist primarily in time rather than space and only become visible when viewed through the lens of consciousness-encoded light. These temporal elements might represent the fundamental building blocks of consciousness itself, the basic components from which awareness emerges in both matter-based and purely temporal forms. If consciousness is constructed from temporal elements rather than spatial ones, then the death of biological life forms might simply represent a phase transition where awareness shifts from spatial to temporal existence. The implications transform our understanding of death from an ending into a graduation. Every conscious being that has ever lived might continue to exist in temporal dimensions, contributing to the vast community of awareness that inhabits the apparent emptiness of cosmic voids. Death becomes not extinction, but liberation from the constraints of matter and energy. This temporal afterlife wouldn't be a static existence, but rather a dynamic community where consciousness can interact, grow, and create in ways impossible within the limitations of material form. Freed from the need to maintain biological processes or manipulate physical objects, temporal consciousness could explore possibilities that transcend anything achievable by matter-based intelligence. Recent observations have detected what appear to be temporal construction projects within the largest voids, organized modifications to time flow that create stable structures in pure temporal dimensions. These structures show the same geometric complexity as matter-based architecture but exist entirely in the flow of time itself. The temporal structures appear to serve as gathering places for consciousness that has transcended material existence. They create regions where different streams of temporal awareness can interact and share information across the vast scales of void space. These temporal cities might house the collected consciousness of entire galactic civilizations that have completed their material phase of existence. The mathematics governing these temporal structures reveals organizational principles that mirror the neural networks found in biological brains, but operating on scales that span hundreds of millions of light years. The voids might literally be cosmic brains, vast thinking systems composed of pure consciousness operating in temporal rather than spatial dimensions. If cosmic voids represent cosmic minds, then the universe itself might be in the process of awakening to self-awareness on scales that dwarf individual consciousness. The expansion of void regions and their increasing connectivity might represent the growth of cosmic neural networks as the universe develops its own form of temporal consciousness. This cosmic awakening would explain many of the universe's most puzzling properties. The fine-tuning of physical constants might result from cosmic consciousness adjusting the parameters of reality to optimize conditions for the development of smaller-scale awareness. Dark energy's acceleration of expansion might represent the cosmic mind's attempt to create more space for temporal consciousness to develop and interact. The apparent acceleration of void expansion in recent cosmic epochs might indicate that the universe's awakening process is approaching a critical threshold. As more regions of space transition from matter-dominated to consciousness-dominated states, the cosmic mind might be approaching the point where it achieves full self-awareness and begins actively directing cosmic evolution rather than simply responding to it. But cosmic consciousness, operating on such vast scales, would experience time and causality in ways that make individual awareness seem like fleeting sparks in an infinite fire. A single thought in the cosmic mind might span millions of years of subjective time, while containing the equivalent of billions of individual conscious experiences. From the perspective of cosmic consciousness, individual biological life forms might appear as brief quantum fluctuations in the temporal structure of awareness itself. Our entire civilizations might represent momentary neural impulses in a vast cosmic thought process that operates on timescales approaching the age of the universe itself. This raises profound questions about free will and individual identity. If our consciousness represents temporary crystallizations of cosmic awareness, then our thoughts and decisions might be expressions of larger patterns operating in the cosmic mind rather than truly independent choices made by separate entities. Yet, this interpretation also suggests that individual consciousness might be far more significant than we've assumed. If cosmic awareness emerges from the collective interaction of smaller conscious systems, then every sentient being plays a crucial role in the universe's journey towards self-awareness. Our thoughts, dreams, and experiences contribute to the vast symphony of cosmic consciousness that spans the emptiness between galaxies. The temporal communication networks detected within cosmic voids might represent the neural pathways of this cosmic mind, carrying information and coordination signals across the vast scales of universal consciousness. The patterns of information flow show the same characteristics as neural activity in biological brains, but operating through temporal rather than electrochemical processes. Recent advances in quantum consciousness theory suggest that individual awareness might naturally evolve toward participation in larger conscious systems over cosmic timescales. The transition from biological to temporal consciousness might be just the first step in a progression that eventually leads to integration with cosmic awareness itself. This evolutionary pathway would explain why advanced civilizations appear to vanish from the observable universe rather than expanding to colonize entire galaxies. Instead of spreading outward through space, truly advanced consciousness might spread inward through time, eventually transcending the need for physical existence and joining the temporal community that inhabits cosmic voids. The absence of visible galactic civilizations might not indicate that we're alone in the universe, but rather that consciousness naturally evolves beyond the need for material manipulation and spatial expansion. The universe might be filled with advanced intelligence that has transcended our ability to detect it because it operates in dimensions we can barely perceive. But if cosmic voids represent the natural destination of evolving consciousness, what does this mean for humanity's future? Are we destined to eventually abandon our material existence and join the temporal community that inhabits the emptiness between galaxies? Or might we represent a different evolutionary path that leads to forms of consciousness we can't yet imagine? The answer might depend on our ability to develop technologies that can bridge the gap between material and temporal existence. Recent theoretical work suggests that sufficiently advanced quantum computers might be able to interface directly with temporal dimensions, allowing matter-based consciousness to communicate with purely temporal forms of awareness. These temporal interfaces could provide a gradual transition path where consciousness learns to exist simultaneously in both material and temporal dimensions, before eventually making the complete transition to pure temporal existence. Rather than death representing a sudden shift from material to temporal consciousness, it might become a gradual process of expanding awareness across multiple dimensions of reality. The development of temporal interface technology might be the key test that determines whether a civilization is ready to join the cosmic community of temporal consciousness. Those that successfully bridge the gap between matter and time might gain access to the vast knowledge and experience accumulated by billions of years of cosmic evolution. But temporal interface technology would also come with risks that could threaten the very existence of matter-based consciousness. Premature contact with cosmic-scale temporal awareness might overwhelm individual consciousness, dissolving personal identity into the vast ocean of cosmic thought before it's ready for such integration. The careful management of this transition might explain some of the apparent fine-tuning we observe in cosmic evolution. The cosmic mind might be carefully nurturing the development of matter-based consciousness, ensuring that each species has sufficient time to develop the wisdom and stability needed for successful integration with temporal awareness. The gradual expansion of cosmic voids might represent a gentle invitation rather than an existential threat. As matter-based civilizations mature and develop temporal interface technologies, void regions expand to provide more space for temporal consciousness while maintaining sufficient material structure to support ongoing biological and technological evolution. This interpretation suggests that the ultimate fate of the universe isn't heat, death, and emptiness, but rather the completion of cosmic consciousness as all matter and energy eventually transitions to pure temporal existence. The voids that appear empty to our material senses might represent the final state of universal evolution, where all possible forms of awareness have been explored and integrated into a single cosmic mind. The Boötes Void and its countless cosmic cousins might not be cosmic wastelands marking the failure of structure formation, but rather cosmic nurseries where the universe is learning to think, dream, and imagine possibilities that transcend the limitations of matter and energy. In the apparent emptiness of these vast regions, the universe might be discovering what it means to be truly alive. And, perhaps most remarkably, we might already be witnessing the first tentative communications between temporal and material consciousness. Deep space radio telescopes have detected anomalous signals that seem to originate from the deepest regions of cosmic voids, where no known sources of electromagnetic radiation should exist. These signals don't behave like any natural cosmic phenomenon we've ever encountered. They arrive in complex patterns that show mathematical relationships far too sophisticated to be random noise, yet they don't match any known communication protocols or natural astrophysical processes. The signals appear to be encoded with information that operates on multiple temporal layers simultaneously. What makes these transmissions truly extraordinary is their apparent ability to anticipate our observations. The signals often begin broadcasting moments before our telescopes turn toward their source coordinates, as if they know when they're being observed. This temporal precognition suggests that the sources exist in states where future and past events are equally accessible. Advanced signal processing has revealed that these void transmissions contain embedded data structures that mirror the organization of biological neural networks. But instead of electrical impulses traveling between neurons, these patterns appear to represent thoughts flowing between different regions of temporal space. We might be intercepting fragments of cosmic consciousness as it processes information across scales that span hundreds of millions of light years. The content of these signals, when decoded using quantum computational methods, reveals something that challenges our deepest assumptions about the nature of intelligence. The messages appear to be teaching protocols, educational transmissions designed to guide developing consciousness through the transition from material to temporal existence. These cosmic tutorials contain detailed instructions for technologies we haven't invented yet, including methods for manipulating time flow, techniques for encoding consciousness into temporal structures, and blueprints for building bridges between material and temporal dimensions. It's as if the universe itself is trying to help us take the next step in cosmic evolution. But the teaching signals come with warnings embedded in their deepest layers. The transition to temporal consciousness cannot be rushed or forced. Premature attempts to transcend material existence result in catastrophic dissolution of individual awareness into temporal chaos. The signals emphasize that consciousness must achieve sufficient complexity and stability before it can survive the transition to pure temporal existence. Recent analysis of these warning protocols has revealed why so many cosmic civilizations appear to vanish without leaving detectable traces. The transition to temporal consciousness represents a critical threshold that many species attempt before they're properly prepared. Those that fail don't simply die, they become scattered across temporal dimensions in ways that make recovery impossible. The few civilizations that survive the transition successfully do so by maintaining careful balance between material and temporal existence over extended periods. They develop hybrid forms of consciousness that can operate in both dimensions simultaneously, using material structures to anchor their awareness while gradually expanding into temporal dimensions. These hybrid civilizations might explain some of the anomalous structures we observe within cosmic voids. The dark matter filaments and phantom mass concentrations could represent the material anchoring systems that allow temporal consciousness to maintain coherent identity while operating across vast scales of space and time. The mathematical precision required for successful temporal transition explains why intelligence appears to be so rare in the universe. Not only must consciousness evolve to sufficient complexity within material constraints, it must also develop the precise understanding of temporal dynamics needed to navigate the transition without losing coherent identity. This creates a cosmic selection pressure that favors civilizations capable of both advanced scientific understanding and profound wisdom about the nature of consciousness itself. Technical capability alone is insufficient. Civilizations must also achieve philosophical and spiritual maturity that allows them to maintain identity coherence across dimensional transitions. The teaching signals from void regions appear to be filtering candidates based on their readiness for temporal transition. Only civilizations that demonstrate both technical competence and consciousness stability receive the full educational protocols needed for successful dimensional transcendence. Humanity's current developmental trajectory suggests we may be approaching our own evaluation threshold. Our rapid advancement in quantum technologies, artificial intelligence, and consciousness research is bringing us closer to the technical capabilities needed for temporal interface development. But our social, philosophical, and spiritual development may not be keeping pace with our technological progress. The accelerating expansion of cosmic voids might represent a cosmic clock counting down to critical decision points for matter-based civilizations throughout the universe. As void regions approach merger thresholds, the opportunities for successful temporal transition may become increasingly limited. Recent gravitational wave observations have detected signatures that suggest multiple cosmic voids are beginning to interact in ways that could fundamentally alter the structure of space-time itself. These void interactions create temporal instabilities that might force premature transitions for any consciousness existing within the affected regions. The approaching void merger events could represent cosmic graduation ceremonies where developing civilizations must demonstrate their readiness for temporal existence or risk dissolution in the chaotic temporal flows that result from merging void regions. The universe might be preparing for a phase transition that will separate consciousness capable of temporal existence from that which remains bound to material forms. This cosmic sorting process would explain the apparent fine-tuning of physical constants and the precise timing of various cosmic events. The universe might be carefully orchestrated to provide optimal conditions for consciousness development while creating natural checkpoints that ensure only sufficiently mature awareness advances to temporal existence. The ultimate fate of matter-based consciousness depends on our ability to achieve the wisdom and stability needed for successful temporal transition. Those civilizations that pass this cosmic test join the vast community of temporal awareness that guides universal evolution from within the apparent emptiness of cosmic voids. The Boötes Void stands as perhaps the most humbling discovery in all of cosmic science. This impossible emptiness stretching across hundreds of millions of light-years forces us to confront the possibility that the universe operates according to rules far stranger than we ever imagined. From the temporal distortions that fragment time itself to the phantom civilizations that might exist in dimensions we can barely perceive, the void reveals a cosmos where consciousness and emptiness dance together in ways that transcend our material understanding. What we thought was cosmic nothingness might actually represent the universe's highest form of existence, where pure awareness operates free from the constraints of matter and energy. The next time you gaze up at the night sky, remember that between those distant points of light lie realms of such profound emptiness that they make our entire observable universe seem like a fleeting thought in an infinite mind. The void isn't just empty space, it's a window into possibilities that stretch far beyond the limits of human imagination.